All right, so let's talk about higher degree polynomials. And polynomials, this is a definition of it. It looks complicated. Here's the main thing you have to know. N is a non-negative integer, okay? So that means that every exponent is a positive integer, and they count down from the highest exponent down to the last. And these terms are your coefficients, okay? And the lead coefficient is not 0. Okay, so if you've got all that stuff, you've got number times x to the n plus another number times x to the n minus 1, all the way down to just a constant by itself, then you have a polynomial. And the highest exponent is your degree of your polynomial. And the lead coefficient is called the leading coefficient. One of the simplest polynomials we work with are the polynomials we call power functions, okay? So once again, if n is a positive integer and the coefficient is not equal to 0, then this simple little function, a number times x raised to a power, is called the power function of degree n. So for example, if I have f of x equals 6x cubed, well, that's a power function of degree 3. Now, power functions with even powers, say 2, 4, 6, 8, look like this. So if this is my x-axis and this is my y-axis, then power functions with even powers basically look like parabolas, okay? So, and then the greater, so if this was y equals x squared, then y equals x to the 6th might come down a little more like that, okay? So this might be y equals x to the 6th, but they all have that basic parabola shape. Power functions with odd powers look like this. So once again, if that's the x-axis, that's the y-axis, well, they're always going to start in the third quadrant and go up like that. Okay, and if they have, so let's say this is y equals x cubed. Now what if it's a negative term? Well, if I have y equals negative x to the 5th, it might look like this. It starts in the second quadrant and goes down through the fourth quadrant. All right, so what are real zeros of polynomial functions? Well, if f of x is a polynomial and a is a number that makes that polynomial equal to 0, then we can call a solution of the polynomial, a root of the polynomial, or a 0 of the equation, f of x equals 0. This also means that x minus whatever a is a factor of f of x. So let's say that f of 3 makes that whole polynomial equal to 0. That means that x minus 3 would be a factor of that polynomial. Okay, now factors don't have to be raised to the power of 1. You can have them raised to any power. And so if I have f of x equals x minus 3 squared, then this is a polynomial where the factor has a multiplicity of 2, because that is the exponent of the factor. So here's an example using the terms we've just defined. Find all the real zeros and state their multiplicities of the polynomial function f of x equals 4x squared times x minus 1 squared times x squared plus 4. Okay, so we're supposed to find real zeros here. Keep that in mind. Okay, so I'm going to take each factor and I'm going to set it equal to 0. All right, so this says that x equals 0, and since we have an exponent of 2, it has a multiplicity of 2. This says that x equals 1, because x minus 1 equals 0, that means x equals 1, and it also has a multiplicity of 2. Now this says that x squared plus 4 equals 0, so x squared equals negative 4. Well, you can't get a real solution from that equation. No real solution. So these are the real zeros with their multiplicities for this polynomial. Now this example flips things around. Now we're told what the zeros are, and we're supposed to find a polynomial that has those zeros. So here we go. I'm going to say that f of x equals some number times x minus negative 2 times x minus 1 times x minus 0, so that's just x, times x minus 3. And then I could make a anything I want, and it would fit that condition, those conditions there. So just to be simple, let's just make a equal to 1, but any value of a would work. So I'm going to say that f of x equals, I'm going to bring this x around front here, and it's going to be x times x plus 2 times x minus 1 times x minus 3. And you can just leave it in factored form. All right, so here we're given a polynomial, and we're supposed to do several things with it. First, we're going to list each real zero and its multiplicity. Well, to find the zeros, we're going to try and factor it, okay? So I hope you notice that I can take an x out of all these terms. So I'm going to set the whole thing equal to 0 and factor out an x. And you'll notice that x squared minus 6x plus 9 factors into x minus 3 squared. So now I know what my zeros are. My zeros are 0, multiplicity of 1, and 3, multiplicity of 2. Okay, so these zeros right here, this number and that number, are places where the x-axis, where the graph touches the x-axis. Now, it may actually touch it and turn around and go back, or it may cross the x-axis. How do we know what it does? Well, if it has an odd multiplicity, it will cross. If it has an even multiplicity, it just touches it. Okay, so let's write that out. Touches at x equal 3, crosses at x equals 0. All right, now we're supposed to find the y-intercept and a few points on the graph. So I'm going to set x equal to 0 to find the y-intercept. And it's pretty obvious we're going to get 0, so we have a y-intercept at 0, 0. And let's find a few points on the graph. So I'm just going to do an f of x chart. Okay, and I've got 0, 0. And remember, up here we figured out that we have x-intercepts at 3 and 0. So we have 3 and 0. And let's do some points in between, okay? So how about 1 and 2? Okay, so if I put in f of 1, that's going to be 1 cubed minus 6 times 1 plus 9 times 1, which is 4. And let's put in 2, and that's going to be 2 cubed, which is 8, minus 6 times 4, which is 24, plus 9 times 2, which is 18. So it's going to be 8 minus 24 is negative 16, plus 18 is 2. Okay. Okay, so determine the end behavior. Okay, so this is an odd degree, which means it's going to be going either like this or like this. So how do we know which way it goes? Well, we're going to look at the lead coefficient, and the lead coefficient is, hang on a minute, didn't mean to do that. The lead coefficient is positive, which means that it will increase as we go from left to right. So our end behavior is it's increasing as we go from left to right, and it's decreasing as we go from right to left. And now we have enough information to get a pretty good sketch of the graph. So you remember that we have a point at 0, 0. We had a point at 1, 4. We had a point at 2, 2. We had a point at 3, 0. And remember that we knew it crossed at 0, 0. And then it just touched at 3, 0. And so that is our graph of the function.